So here we perform a measurement on Ludox TM50 sample. So this is silica nanoparticles, and the sample, the TM50 sample, is diluted at by a factor 100. So we are 0.5 weight portion. And so there are a few things to set before starting the measurement. So the first thing will be to choose a name for your measurement. So here I have written measurement. Then you have to select the solvent. So we're working in water, but you can't use this arrow here to select different kind of samples. And you doesn't see your solvent in this shortlist. You have access to the whole database by clicking to this solvent button here. So here you have access to a very large database. Okay, and if you want to see your solvent in the shortlist, you can just click on this box and then validate. Okay, but here we work in water, we just select water. Then you have to select the temperature control. So even if you don't have any temperature controller, like in this case, you can just click on sensor. So you will measure the room temperatures or the sample temperatures if you plunge the probes in the sample this way. Or if you know the value of the sample temperatures, for example, if you hit him with any heating plate, you can't manually select your temperatures. But in this case, I will just use the instrument probe and select sensor. Then the next step will be to control, adjust the laser power. So what we have seen in the previous measurement. So after having aligned the samples to the laser beam, to the in situ cell, just move this button here to adjust the power of the laser beam, okay, to adjust here the total scattered light detected. So it doesn't matter to be so you should adjust any value to be between few kcps, which is the number of contained photon, to 10,000. In fact, you have to be in the green or the yellow area. By reaching the red area here, you take risk to saturate the detectors. So please adjust the power of the laser beam to be in this green or yellow area, and then it's done. You can validate your setting. So then you can eventually change the kind of experiment you will done. So here we are by default set on a mono acquisitions. That means that we will make a continuous measurement that we will manually start and manually stop. Okay, so I will not go into the detail then, and that's all for the basic things to set your acquisitions. So here the correlator settings, you will find some tau channel settings, but which are not important to make your measurement. It's only dedicated to the Padé-Laplace algorithm. So I will show you that you have three kind of algorithms, three solutions, but you will have mainly need to use the cumulant and the SBL algorithm. So don't mind about these parameters. They are not critical for basic measurement using SBL and cumulant. So let's start the measurement. So you have to click outside the SOP panel after your adjustment. Okay, so now you see the measuring windows, and then you can start. You can push. You can switch the start button. So here you see that after really few seconds, you have the correlation function corresponding to your samples. And so this is the live correlation functions, and on this screen here, on this window, you have the total scattering intensity detected by the instrument. So you see the normal fluctuation of induced by the Brownian motions of the particles. So at any moment you can stop the measurement by clicking on this button, and then it will be automatically the software will automatically process the data using the 3 algorithm. So here you can see that a new windows has appeared, so showing the different solutions. So here you have the solutions given by the cumulant algorithm, here by the Padé-Laplace algorithm, and here by the SBL algorithm. In each case, you can also have a look on the residue by clicking on this button. So the residue are the difference between the fit given by the algorithm, so in green, and the experimental data points, which are the blue point here. And the residue are represented by this yellow dots here in line. So a good solution is obtained when these residue are the smaller possible, and that should be really between these 2 red threshold points. So if you have some of these yellow points out of this these thresholds, it means that your solutions is not quite accurate. But in this case, you see that it's okay. So the result given by the cumulant algorithm is, for example, here the average of 32 nanometer approximately. So for each algorithm, you can also have access to more data just by clicking on this icon here. So for example, with the cumulant algorithm, you will see so the average, but also the PDI, which is an important parameter for the cumulant algorithm here, the different DI, but you can also see the DV, the DN, just by changing the representation. So by default, note that the distribution is represented in intensity. That means that the amplitude of each populations is weighted by the intensity of light scattered by the populations. But generally, you want to see these distributions in terms of volumes or number. So this is the different representation. So when you shift these representations, let's go to the volume representations, you will see that here you will have the DV10, the DV50, the DV90, for example. You will also have some other information like standard deviations, mean diameter, and some other information about your measurement. So you will see approximately the same kind of information in Padé-Laplace. In SBL, you have something more. It's called the L curve that you have here. Okay, so the L curve gives the different possible solutions that are possible with this kind of signal. So I don't know if I go too much in detail here, but to be just to summarize this, You have a parameter here you can change, in which you can see different shape of the distributions and see the corresponding residue of the solution. So if I select, for example, a very large distributions, for example this one, you can see that the fit is not really good. So that means that the solution is not quite good. So that means that yes, your distributions is better, has better residue with this L-curve criteria having a higher value. So maybe I will explain it in another video to more in detail.